The diagram shows the cross section of a roof. DC is equal to 3.6 meters. BD is equal to 2.9 meters. And angle DAB is equal to 22 degrees. And so here we have a diagram right here. And it says, calculate, given your answer to 1 decimal place, the length of BC. And so we need to determine the length of BC. So here we have the length BC right here. And notice that BC is one of the side lengths of this right angle triangle. This is BC, all right? And so we have this right angle triangle, and we have it labeled. So C is the hypotenuse, that's the length, right? That's the length that is opposite, or that's the side rather, that's opposite the right angle right now. And A and B are the other sides of the right angle triangle. And so we're going to use the Pythagoras theorem, which states that C squared is equal to A squared plus B squared, where C is the hypotenuse, and in this case, C is 3.6, and A is 2.9. And so we have 2.9 here, and we have to figure out what is the length, or what is the measure of B, all right? And so the first thing we're going to do is we're going to say 3.6 squared, which gives us 12.96. 2.9 squared is 8.41. And what we have here is we put back the B squared. We're going to take 8.41 and send it over the equal sign. And so that gives us 12.96 minus 8.41, which gives us 4.55. Now we have to take the square root of both sides of this equation. And when we do that, we have the square root of 4.55 is equal to the square root of B squared. This cancels with that. And so we are left with B is equal to 2.133072901. That is the square root of 4.55. But the question says they want our answer to be correct to 1 decimal place. And if you look carefully, you see that this is 3. Once we have a number less than 5, we do not round up. And so all we have here is just 2.1. And so 2.1, so B is equal to 2.1. And that means that BC, right, the length of BC is going to be 2.1 meters. And that's the answer for this question. Next, the question states that they want us to calculate the length AD. So they want us to calculate the length AD. Where is AD? Well, AD is right here. This is AD. And notice that the side that is opposite the given angle, we call that side the opposite side. The side that is opposite the right angle, we call that the hypotenuse. And the side that is left, we call that the adjacent. So AB is the adjacent side, right? And so notice that our goal is to determine what is the length of AD. So we need to figure out what is the hypotenuse, right? What is the length of this hypotenuse? And in order to do that, we're going to use sine. All right, we're going to use the sine ratio. And the reason why we're going to use that is because we are dealing with the hypotenuse and the opposite. We are trying to find the hypotenuse, and we have the opposite side. And so that means that since we're dealing with these two sides, we have to use the sine ratio. Now, the opposite, we know what that is. That's 2.9. The hypotenuse, we do not know what that is. So we're going to call it x. And we put 22 degrees because that's what theta is. Theta is the given angle. And we put it over 1 because we want to cross multiply these two fractions. And so we have x multiplied by sine of 22, and we have 1 times 2.9. When we multiply, when we cross multiply, we get the x times sine of 22 is equal to 2.9. And so what we're going to do here is we're going to divide both sides by sine of 22. And so what we do here is we cancel this one with that one. So we get that x is equal to 2.9 divided by sine of 22. And so we have 2.9 divided by sine of 22, which means that x is going to be equal to 7.7414547771. But they want us to give our answer correct to 1 decimal place. Notice that the number behind the 7 is 4. And once it's less than 5, we cannot round up. So we just left with 7.7. So that means that the length of AD is equal to 7.7. Next, we need to determine the angle BCD. Now we have B, we have C, and we have D. What they really want us to figure out is what is the measure of this angle, right? And so we call this angle theta, and the side that is opposite theta, we call that the opposite side, okay? The side that's opposite the right angle, we call that the hypotenuse, and this side, BC, well, that is the adjacent. Now, what we have here is we need to figure out what is this angle, okay? We know what is the opposite side. We know what is the hypotenuse. The opposite is 2.9, the hypotenuse is 3.6. And so we're gonna use the sine ratio, all right? Now, what is the opposite? The opposite is 2.9, so we substitute that in. What is the hypotenuse? The hypotenuse is 3.6. What is theta? Well, theta, we do not know what theta is. And so that's what we're trying to figure out. So we're gonna take sine inverse of both sides. Sine inverse of sine theta is equal to sine inverse of 2.9 all over 3.6. Next, we cancel this one with that one. So we get that theta is equal to sine inverse of 2.9 all over 3.6, which gives us theta is equal to 53.66394249. But we want to write our answer correct to 1 decimal place. And so notice that here, this is 6. And so since this is 6, once it's 5 or greater, we add 1. So we add 1 to the 6. So it's going to be 6 plus 7. And so we have that the theta is equal to 53.7. And that's the answer to this question. Angle BCD is equal to 53.7 degrees. And that's the answer to this question.